Have you ever seen a cartoon of an opera singer, usually a soprano, who strikes just the right high-pitched note and suddenly all the windows and glass in the room shatter? This is how Anthony Holland, Ph.D., a renowned composer turned cancer researcher, described what happened when he unleashed just the right combination of frequencies onto microorganisms in a lab. They shattered. His work first started against harmless microorganisms, paramecium and blepharisma. Dr. Holland gathered the required electronic components and built a frequency machine. It took 15 months and hundreds, if not thousands, of frequency combinations before the magic combination was reached. Dr. Holland told Thomas Jefferson University, where he conducted some of his research, "I learned to use microscopes and to grow and safely keep bacteria, and later cancer cells, in an incubator. I began to try different frequencies, and at first nothing happened. Then I tried putting more than one frequency into the organism simultaneously. If I added one additional frequency, in a special relationship to the first frequency, I realized I'd be creating more power and have a better chance at landing on the frequency necessary to change the organism. When I added the 11th harmonic, I looked through the microscope and discovered that the microorganism had shattered. It reminded me of how a crystal glass shatters when a soprano hits just the right note." His later research showed that specific microorganisms could be targeted with specific frequencies, leaving other nearby organisms unharmed. Dr. Holland invited a cancer researcher to view videos of the organisms disintegrating in response to the frequencies and was invited to test his method on cancer cells. Pancreatic cancer cells were targeted first. The resonant frequencies lead to changes in the shape of the cells and eventual destruction. Dr. Holland figured out that cancer cells are vulnerable to frequencies between 100,000 Hz and 300,000 Hz. His team tackled leukemia cells next, which were similarly destroyed. In further studies, the frequencies, known as oscillating pulsed electric field (OPEF) technology, destroyed an average of 25% to 42% of leukemia cells, and sometimes as high as 60%. The treatment also slowed the growth of cancer cells by up to 60%. Ovarian cancer cells also succumbed to OPEF, as did antibiotic-resistant bacteria including methicillin-resistant Staphylococcus aureus (MRSA). The electronic signals not only rendered MRSA vulnerable to antibiotics but also slowed its growth. Dr. Holland's hope is that one day soon the frequencies, which appear to be just as destructive to cancer cells as medications and radiation, but without the toxicity, will become the future of cancer care. He said, "I now believe that the future cancer treatment rooms for children will be a very different place. It will be a pleasant place where children gather and make new friends. They probably won't even know they're sick. They'll draw pictures, color in their books, play with their toys, all the while unaware that above them beautiful blue-pinkish plasma lights are emanating healing, pulsing electric fields, shattering their cancer painlessly and non-toxically one cell at a time."